Okay, folks, so we are going to get started here. I'm going to start back over and get Discord popped up. If you guys um, have any questions, you can type it in the chat. So, chapter 7 was uh, going backwards, through the chapters. I think we just left off on chapter 15, so we're kind of bouncing around. Chapter 7 is over handling exceptions primarily. There's also some data validation that's covered at the end of chapter 7. And so, what is exception handling and why is it important? It's always good to start with the question of why are we learning this? And so, exception handling is used in object oriented languages. It's an object oriented approach to handle errors that specifically crash your application. And so you've seen exception handling quite a bit. For example, you ask a user to enter their age, and instead they give you like the word TEN, like I'm 10, and you're expecting a number, they give you a letter, and that crashes your program. And you get a little error dialog box maybe that tells you that an exception occurred, and it crashes. And so, we're going to learn a way to stop that from crashing your program altogether, and maybe keep the program running. And so we're going to learn again what is an exception, and I kind of explained it. It's an error condition that occurs when your program is running that crashes your program. And what does it mean for an exception to be thrown? What does it mean for an exception to be handled? And so those are just the terminology, right? You throw an exception and you catch an exception, which is known as handling it, right? So throwing an exception is the term that means the exception has occurred, right? The exception was thrown, and catching the exception means that the program did not crash. The exception was caught or handled. And so when you say thrown, you could also say the exception was triggered or the exception occurred. Again, there's always so many different ways of saying something in C sharp. And then caught or handled, it means that instead of crashing the program, we wrote some code to handle that occurrence. Uh, Exceptions are classes, and so they have a hierarchy, just like all of our other classes in the .NET framework. And so we're going to learn a little bit about the exception hierarchy. The code that we're going to learn is a try-catch statement. And so this is going to be the C# code that we write to handle our exceptions. We're going to learn some properties and methods that are going to help us to work with exceptions. We're going to learn why we might throw. There are conditions where we might throw an exception. And so why would we manually throw an exception? A lot of times exceptions occur naturally or organically, right? They just happen through the execution of the code. But you can manually throw exceptions, and we will be doing that in our labs. Then the last couple of objectives here are the different types of data validation and some methods that we're going to learn to write. And so here in slide number 4, if you're following without the video stream, slide number 4 is a picture of an unhandled exception. So the way an exception works is that let's just say you've got several methods that you're working with. So let's just say you're working in the main method, right? And the main method is where the program starts. And then the main method calls a method called method 1, and then method 1 calls method 2, and then method 2 calls method 3. Well, you could be executing code in method 3. Excuse me. Someone's going to make a joke about the virus. You could be executing code in method 3, and that logic could cause an exception to occur or an exception to be thrown, which is going to is going to crash your program. And so method three would try and handle the exception. If if method three is unable to handle the exception, it would pass it up to method two. Method two would try and handle the exception. If method two can't handle the exception, it passes it up to method one. If method one can't handle it, it passes it up to the main method. If the main method can't handle it, then it crashes, right? So that's your program crashes. That's what you see here. If you run your program in debugging mode, um, you'll see something like this: format exception was unhandled, and you'll see the type. This is the exception type. This is a class called format exception. And format exception occurs if you look at the line of code when you try and convert to a data type and the conversion doesn't work, right? It's a format exception. And so there they're trying to convert to a decimal. And so this is what you've probably seen 100 times in this class so far are these exceptions that have occurred. They just crash your program and you just reran the program, or maybe you wrote a little bit of code to try and handle it without uh, working with try catch blocks. And so there is what's called structured exception handling, and that's what we're learning here. So the full name for what we're learning isn't just called exception handling. They call it structured exception handling. And that is an object-oriented approach for handling these errors that crash our program. Now, before object-oriented languages, obviously they handled these errors differently. They didn't handle them with classes, right? And um, methods and properties that belong to those classes. Before structured exception handling, we just had traditional error handling. And when I say traditional error handling, I'm talking about for loops, I'm talking about if statements, you know, and just the things that we've been using so far that can help us to keep our programs from crashing. And so object-oriented languages came around. They made this newer approach that is an object-oriented approach to keep your programs from crashing. And these object-oriented approaches, they're meant to give you details around the error that occurred, right? They're meant to be good descriptions around what caused your program to crash, primarily for the programmer to read the descriptions and decide if they want to keep the program from crashing. you know, they could use some of these classes to keep that from happening, right? So this is really meant to be used by programmers to inspect the error messages that are occurring and decide, let the programmer decide, or the manager or whoever, if they want to keep the program from crashing. Now, that's an interesting thought, because you say, well, why wouldn't you want to keep the program from crashing? Well, sometimes, you know, there are more mission critical applications that need to stay running than uh, than other apps that aren't as mission critical. A good example of that right now, we got all this virus stuff going on, and the coronavirus and whatnot. And I know that telemedicine is blowing up right now. I know a nurse in the space, and the nurse is literally helping. She's kind of, yeah, she's on the front lines as a nurse, but at the same time, she's helping to develop an app and in this telemedicine space. Well, in telemedicine, you're monitoring patients remotely, and at the other end of this application, you have a person that's, you know, life and death scenario, could be a pretty critical scenario. So you can't have that program crashing. Telemedicine applications way more critically important than, for example, maybe my TurboTaxes. I'm just entering in my tax information, and if my TurboTax crashes, well, I might have to re-enter some data, or Microsoft Word, I might have to retype out my paper, but you're not talking about life and death. If Microsoft Word crashes versus a telemedicine application, right? So it was a learning experience for me to learn that what, not all scenarios are equal, and that you're not going to use you're not going to use structured exception handling in all applications or in every scenario, right? Some scenarios, it's just okay that the program crashes. It's just a decision that you or your boss makes that the program crashes, you reboot it, and you type in some more information. And that's just what it is. I had an alumni some years ago, uh, tell me that he worked at the United States Post Office, and he was a developer for the post office. And he told me that the app that he was working on had no error exception handling, had no exception handling. They did not use try catch blocks or any of these exception classes in the application that they were working on. They just used the traditional error handling with the for loops and the if statements, and that got the job done for them. So that's just something to keep in mind. Also, so it's not for every application, it's not for every scenario. In fact, built into the name is uh, it tells you a little bit about how often it should be used. This is called exception handling. You know, the the idea is that you should use this as the exception to the rule, right? You don't use this for scenarios that are occurring frequently. You should use this for scenarios that are occurring as the exception to the rule. In other words, not frequently. I've heard, a general recommendation, if if this is occurring frequently, um, in other words, 4 out of 5 times the user runs a program and it's crashing, you might find another solution instead of using a try catch block. You should only use this as the exception to the rule. If maybe 1 in 5, maybe 1 in 10 times that this is occurring, should you use exception handling? Okay, so just a couple tidbits of information there. Um, Looking at this screen, you got the exception class. That's the parent class of all exception classes. Again, this is an object-oriented approach. There's a class hierarchy. Format exception we already covered. Format exceptions, you're trying to convert one type of data into another and it doesn't work, you get a format exception. Arithmetic exception is this idea of um, something, a math type problem. Overflow exception is the idea. Arithmetic exception is obviously math, and overflow exception is, hey, as a result of some math, let's say you did some arithmetic, right? And you got this really large number, and you tried to store that large number into a byte, which is a small container, a small data type. Um, you're going to get an overflow exception. Basically, the result of the math is too big to store in a data type that you're trying to store it in, and so that's an overflow exception. And then obviously divide by zero is something you can't do. So if you attempt to divide by zero, that'll crash your program, and it'll throw an exception said divide by zero. And so you can see here that any particular method, like if you look at this um, slide 6 will show you that this convert class, the two decimal method, can actually cause a couple of different exceptions to occur. It could be a format exception or it could be an overflow exception. And so those are two exceptions that could occur if you call the two decimal method of the convert class. Same thing here with the decimal.parse. The same exceptions could occur or could be thrown, as they say. Okay, so these methods that are built into the .NET framework, they could cause exceptions to be thrown. And again, once you find out an exception is being thrown, it's up to you to determine if you want to handle that exception. Again, it's not a mandatory thing to handle an exception. Um, this is back in chapter 7, so if you do not remember, but we've been using message boxes along the way. Is it just a line of code that I showed the class? But this is a way. A message box is a way to give an error message to the user. Just real quick, do a little pop-up box, a little message box, a little pop-up, and this could be one way that when an exception occurs, it does stop the program from crashing, which is the main idea. But then what do you do to let the user know that a problem has happened? That uh, hey, you didn't enter a valid number. Please put in a valid number, as it says there on slide 7. So you could do a message box, or you could update a label on your screen, or in some cases, you might just write like an error message into a log. You might log an error message, and then you just might keep the program running. You might not show the user anything. Just might keep the program from crashing, and then let the user, continue to interact with the program. So, the exception occurs, the exception is handled, and then what you do is basically you keep the program running. You might give them an error message, you might not. So that was on slide 7. On slide 8 is the actual syntax for structured exception handling. And you'll see a couple of new statements there. You see the try block and you see a catch block. And so what you put in the try block, now that we're actually looking at some code on slide 8, what you put in the try block is what you expect to potentially throw an exception. Now that doesn't do that every time. Keep in mind, this is supposed to happen. The guidelines that I've come across is less than 1 in 5 times. If this is occurring less than 1 in 5 times, go ahead and put it in a try catch block. And it's crashing your program in less than 1 in 5 times. In the try block is the code that you expect to cause an exception, right? Less than 1 in 5 times, less than 1 in 5 odds. That code there, those 4 lines of code, are going to cause an exception. And we already saw how the 2 decimal class convert 2 decimal that method itself can throw multiple exceptions, right? There was the format exception and the out overflow exception, right? As we saw on that slide. So the try block is where you put the code that you expect to cause a problem, and the catch block is the code that responds that if an exception occurs, you run the code in the catch block. And as I said on slide 7, you might just show the user, hey, this is the problem that occurred. Please try again. Please put in a valid number. So here on slide 9, here's please enter a subtotal, and a little pop-up box shows that, hey, please enter a valid number. Again, a common question and a common thing to think right now is, hey, couldn't I just do that with like a try parse? Couldn't I do that with an if else in a loop? Couldn't I use another approach? The answer is yes. This is just another tool in your toolbox to handle these error conditions that would otherwise crash your program. And the benefit of using try catch over the traditional error handling is that they have built-in methods and built-in properties to tell you about the condition. Okay, and we haven't talked about those methods and properties. But if you're just coding your own if-else statements or you're coding your own try parse, there's no built-in methods to tell the user what's going on or to give you a message, right? You have to understand it and you have to write your own custom message. Instead, if you use a try catch block to handle it, there are some built-in properties that can help you as the programmer display the error message to the end user, right? That you don't get that with if-else statements, right? So that's another important thing that I had to understand along the way is okay, if I can do it using either or, why would I use this object-oriented approach? Why wouldn't I just use the tools that we've already learned? Yeah, good point. And I don't know if Mr. Smith just chimed in. I don't know if that's going to be recorded on my recording. Hopefully, his voice comes across. No, it's not because I don't think the desktop audio. So I'm just going to repeat what Mr. Smith said so that everyone hears it, which was that there are some scenarios that you cannot handle with an if-else statement, such as writing to files, such as interacting with a network. There are some scenarios in your application that exist that you cannot use your traditional tools. Okay. I did mention that there are some built-in properties and methods to all of these objects that contain some built-in information about the exception that could be used in your debugging or that can be used in delivering the message to the end user. Because there's a hierarchy here and we understand inheritance, this exception class makes all of its children implement a message property and a stack trace property. And so a message is just that. It's a generic message that kind of describes the exception. Um, Sometimes they're user friendly, sometimes they're not so user friendly. So if you decide to use that message as displaying that to the end user, that might be a good idea. It might not. You might be able to write a little bit more descriptive error message to the user, but it does exist for that purpose of displaying some, basically what's going on with this exception. And then there's also the stack trace property. And the stack trace is used to help you debug, you know, um, the problem. Again, I use that example of, hey, you're in a main method, and main method calls method one calls method two calls method three, and then method three calls, convert to decimal. And this convert to decimal throws an exception. And it's kind of hard sometimes to know exactly what and to pinpoint the method that threw the exception, right? So the stack trace is exactly what I just listed. It's that list of methods that, hey, this method called this method called this method called that method, and then inside of and this last method, that's where this method caused the exception, right? So it's the list of methods that can help you debug and actually find out where the exception occurred. Because if you're just sitting in main and you're just writing code in main and some method many levels deep, throws an exception, that might be hard to find out where exactly that occurred at. Because what happens again is that exception it bubbles up, and so it tries to be handled in its the method itself. If it's not handled there, it'll bubble up to the prior method that called it and bubble up all the way back to the main method. And so that exception bubbling is this idea of, hey, an exception occurred way down the call stack, and it's bubbling up all the way back to main, and it was never caught. Therefore, it crashes your program, right? If you don't catch the exception, it will crash your program. And then there's The get type method will get the data type of the current exception. In other words, is it a format exception? Is it a arithmetic exception, overflow exception? Which type of of exception is this exactly? Now, to get access to those properties and to get access to those methods, you need to code your exception object. That's done in this catch block here on slide 11, right? So after slide 10, slide 11, we got the try block, and you'll notice catch exception EX. Now, this is good because we talked about inheritance, and we know that child objects can be converted into their parent objects. So any class that is a child of exception, uh, we're just seeing four here. Any one of these four children could be upcast into an exception object, right? So if we're looking at this code, this one catch block could be used to catch any of the children of the exception object. And you'll notice here the identifier is EX, and the type of exception is the parent, is the parent of all exceptions, which is the exception class. And if we look here, we're utilizing that message property. We're calling the get type method. We convert it all to a string. And then we even show the stack trace property. So those two properties and that method get type, you know, a lot of technical information. Again, you're probably not displaying all of this to the end user. Maybe you're just displaying the message to the end user, right? Because most end users would be way overwhelmed by the rest of all that information. So that's why a lot of times when you see exceptions in the real world, like you're just running a program, you just get a real generic error message like maybe just a little, tidbit, you know, a lot of times you've probably seen it as uh, an error has occurred. If this continually occurs, please contact your system administrator, right? And it's just a real generic message because when you start getting at all technical, which that's what the rest of this is, the rest of this is very technical information that is probably meant for a programmer to see, right? As you guys learn about exceptions and you learn about the stack trace and you learn about classes, you know what kind of exception this was. This was a format exception, right? And it begins to tell you that this was thrown at the convert to decimal method. That convert to decimal was inside of a calculate button click. That calculate button click belongs to form 1, right? So you can see the stack trace there, and you can see, okay, well, inside of form 1, we got a calculate button click, and we got to convert to decimal. And then I think there's even one more here. There's a parse decimal that's inside of convert to decimal, right? So this technical information, you might not show the end user that. You might just log that into a system log. You might put that into a database log, but it's more meant for a programmer's eyes than an end user's eyes. Now you can have multiple catch statements. Like you see the syntax here, you have one try block, and you can have multiple catch statements. The problem with having one exception here, yeah, it'll catch a broad range of exceptions, and it'll keep your program from crashing with a broad range of exceptions. But the problem is you have to handle all of your catch blocks the same, right? So you might not want that. You might want, if a different exception occurs, you might want to have a different catch block to handle that exception differently than another exception, right? So you can have multiple catches, and after your catches, you might have a finally block. And so a lot of times what you put in a finally block is the cleanup code. And so in your try, you might open a connection to a database, and then let's just say that connection opens, and then you try and write something, and that crashes. You try and write to the database, and that crashes, right? Instead of have to close the connection inside each catch block, right? Close the connection to the database. You close the connection in the finally block. That way you don't have to have the repetitive code inside of each catch because again, you're catching things, in different scenarios. You're handling different scenarios differently. But the finally block kind of wraps it all back together and says, you know what, no matter what happens, let's make sure whether an exception was thrown or not, whether that exception was caught or not, let's clean up tasks inside this finally block. And so on slide 14, we see example of try with multiple catch blocks. A couple things important here. Um, if you were to catch a generic exception before a specific one, then that specific one would never be caught. Excuse me. What I mean by that is because exception is a parent of format exception, if you listed this catch block exception EX, if you listed it that first, and then you listed format exception beneath that, format exception would just be caught by exception. So the important rule here is to list the specific exceptions first, down to the more generic ones later, right? Because keeping in mind that your children could be upcasted into an exception object, so you don't want to list that one first, otherwise all the exceptions would be caught there, right? The idea here is to have different catch blocks so they could handle things differently, and then that way you want to keep the generic ones down below. And you see in this finally block, they just call this method that says perform cleanup. That's a general, that's a general thing that happens inside this finally block. Okay, and if I go back to my hierarchy, right, um, it's mainly you want to code the parents after you code the children. In other words, I would code a divide by zero exception catch block before an arithmetic exception catch block. Okay, so you code the children catch blocks before you code their parents. Okay, but if it's not a parent, it doesn't really matter. In other words, I could code this format exception. Uh, it doesn't really matter because it's not in the same hierarchy as arithmetic exception or overflow exception. So I could code format exception before I code overflow exception, and it really wouldn't matter because it's not a parent of overflow exception. If that, hopefully that makes sense. So that whole rule about what do you code first only applies to parents and their children. Okay, so that was slide 13 and 14. You guys aren't you guys aren't going to be heard, I don't think, on the stream. If you guys doing okay back here on Discord? Good. All right. Any questions so far about anything I've covered? Nice and quiet. Okay. Not nice and quiet. It would be nice if you asked questions. Nice and quiet is not the right expression to use. Please ask questions. Um, Exceptions occur, what I'll say is organically. They just happen naturally when you run your program. You've seen them plenty of times. Um, However, because what you're doing here is keeping your programs from crashing, there could be a specific occurrence in your application that there's not a built-in exception class for. So there could be something that's crashing your program that's so specific that it's not built into the .NET framework. Again, we learned 4 or 5 classes, but we have not learned all of the classes. But there could be a scenario where the built-in .NET framework classes don't have a built-in class to handle your scenario. So In that scenario, you could create your own exception class. And if you were to create your own exception class to handle this scenario that's crashing your application, then you would have to tell your application in C sharp code, okay, here's the scenario. We've met these conditions that's crashing the program. You might have to manually throw that exception. So you see here I'm highlighting on the screen the syntax for throwing a new instance of an exception class. Now that could be an exception class that exists, or it could be a custom exception class. All right, and um, we will be doing this in lab where we create our own exception classes, and then inside of the constructor here, you'll see that you can provide a string, and that string will go into the message property of the exception object itself. Okay, so if you want to throw a new exception, in other words, an exception has not occurred organically, but you're going to cause an exception to be thrown because this is a scenario that was crashing your program and you want to handle it with a try catch block instead of crashing your program, you could throw an exception. And there's also a scenario where you might want to throw an exception that already has been occurred. That occurs naturally, and that exception exists, and you just want to rethrow it. And so there's two syntaxes. There's throw new exception, and then if there's already an existing exception, you could just rethrow that exception, right? And it says, well, when would you throw an exception that already occurred? Well, um, maybe you're just testing an exception and you say, okay, I want to test my exception handler. In other words, I want to test my catch block. So here in this line of my code, I'm going to throw an exception just for the purpose of testing my exception handler. Right? So that's one scenario where you might want to throw an existing exception. And another scenario is if you have a method that is unable to complete its task. And so we'll show an example of this. Where you're unable to complete a task, I think in a slide or two. Right, so in this slide, on slide 16, we see a regular old method that takes in, what, one, two, three parameters. And here's a scenario. The monthly investment was less than or equal to zero. That might be causing your program to crash. And instead of crashing, we throw an exception. Now, this is instead of the exception occurring naturally, we're manually throwing an exception. And the whole point here is to handle this with a try catch block. So this is just part of the equation, right? We throw a new, and we're just throwing a generic exception object. On both these cases, we're just throwing a generic exception object, and then the message property is what goes in the string uh, in the string arguments here. We got two arguments inside here. And so once we've thrown the exception, um, we would use a try catch block later on to handle that. Here is an example of the other, right? So here, oh no, it's still throw new exception. It's the same thing. But what they do is they wrap it in a try catch. The main difference between these two slides, there's no try catch here. If you don't catch this exception, it would crash your program. But what they've done here is they wrap it in a try catch to then keep the program from crashing and give an error message to the end user and some technical information to the programmer. And then so here's an example of what I just mentioned a couple slides up of rethrowing an exception. And so we know that this convert to decimal could cause an exception, a couple of exceptions to occur. And here they catch a format exception. They call the format exception FE. They focus the text box, assuming that's the text box that caused the problem. And instead of handling the exception here in this catch block, they rethrow the exception. So here's that example of the exception already occurred, and we're going to rethrow it we partially handled it here, but maybe we want to finish handling that exception somewhere else in our code, and this would allow us to do that with that throw FE that rethrows an exception. So these were examples of throwing new exceptions. This is rethrowing an exception once it's already occurred. Yeah, no, a good question. So the question was, if you throw an exception, isn't the program over? So not necessarily. If you if you rethrow this exception, um, that exception, what it does is it would bubble up the call stack. And so again, with that, main method calls method one calls method two calls method three, and then let's just say method three has this code in it on slide 18. Um, so you'll notice that method three has a try catch in it. That FE it would bubble up to method two, and it would look for a try catch block in method two. And so if method two had a catch block for another format exception, you could write more code in that catch block that again, it would keep it from crashing, it would not crash your program, and you would finish handling the exception in another method. So for example, does that make sense? Yeah. So if you rethrow an exception, it does not mean that it's going to crash your program. It could, or it could just be caught somewhere else. And so what winds up happening here is it's partially handled in this method, but it would be, the rest of it would be handled somewhere else. Um, if you think of this convert to decimal method, another common question that I get is, well, should I just go ahead and put my try catch in my own methods? Like if I'm writing a method, should I just go ahead and handle the exception in my method? And a lot of times the answer is no. You want to go ahead and let the person using your method write the try catch. Because if you think about convert to decimal, this two decimal method could have a try catch block in it that could handle the exceptions, but it doesn't. Instead, that exception bubbles up to us in the methods that we write, and we get to decide how to handle that. If we handle that, we might not handle, the format exception. We just might say, okay, it's going to crash our program, and that's what it does, and that's fine, right? Or we're going to write a try catch block to handle it. They kind of give the person using the method the ability to determine whether they want to handle it or not. So that exception bubbling is a real nice kind of feature. Okay. Um, all that's left, and that's a high-level overview of exception handling. All that's left is a little bit of code from the book, which I generally, we write our own programs, right? So they give you some textbook examples of try catches in here, but we're not really going to use that too much. Let me see what I can do with this stream. So what I'm going to do is pause the stream, pause the recording. I'll give you guys time to take a break. And then when we come back, I'm going to do a code demonstration using some try catch. Okay? So I'm going to pause it now. Okay, so back from a break, and I was going to do some code example. I was actually going to do the first lab to kind of show some examples and get everyone going. And then what I'm going to ask everyone to do tonight is to work on lab two. Okay, and so you'll be able to work through lab two. My idea is that you put some, and just tonight, you work on it this evening, but obviously tomorrow and the next days you'll be able to work through this in our normal class time. But I am asking everyone tonight to work on this lab two and try and get as far as they can using what they learned from lab one for lab two. So and then assuming we'll get lab two done tomorrow, lab three Wednesday, and lab four on Thursday. So we're doing one today for sure, and then you'll work on this one tonight, and then we'll work through it tomorrow. As of this point, being the situation that it is with remote classes, I'm probably going to be doing a lot more code walkthroughs than normal, just because um, I do want you to critically think through these problems, and I will assign them to you, but I'm also going to just be doing more to help that way. So let me launch Visual Studio here. Windows Form app with a .NET framework. Put this in my repo. Lab, this is chapter 7. And we call this LB1. Um, it's up to you if you want to try and code along. I'm going to put it on YouTube so that if you can't keep up, that you can just, you know, use YouTube. Can everyone see the screen okay? Okay. So if you want to try and code along, that's welcome. Otherwise, no big deal. It'll be on YouTube. So starting with the enumeration, and um, you can see here now that we've got a couple of exception classes, so we're going to create some exception classes, and we've got a BMI calculator, that's the form, and then we've got a class called BMI. Okay, so we got an enumeration called weight category that belongs to our BMI class. So we'll start with the class of BMI and we'll create the enumeration in there. So let's go ahead and add a class called BMI. Let's see if I can zoom in. Yeah, there we go. Normal, underweight, overweight, obese, all caps. All the typos, caps lock, and what am I doing wrong here? Oh, duh. Gotta call it something. Weight category. It is Monday morning. So here we go. Public enum weight category. Now we got a class called BMI. You guys can, instead of alt tabbing, I'm going to drag this to my other screen. As long as you have the UML diagram up, you'll understand why I'm coding the way I'm coding this. Private float. You can feel free to ask questions. I will explain as needed, but these are my instance fields. These are nothing new. Just going off of the UML diagram, public. So we got a constructor. Make sure that's the underscore weight category. And this is not a float, this is a weight category. That's not a float, that was a typo. So now our constructor's built. And we got some properties that just get. So obviously we're going to use the constructor to put data into our fields, and then we're going to use the properties to get the data out. It's been a couple weeks of break, so I'm doing all this longhand. That's my third. And this is the name of the class, which is causing a conflict. The class is called BMI. The property is trying to be called BMI. Um, so that's causing a conflict. So, I mean, if we do that, it solves it. Okay, so that's our enumeration. That's our BMI class. The next thing is our interface, our form. And so let's set this up. Okay, couple labels. Oh, copy and paste. So building out the interface, giving our controls names, button for calculate, and okay. Looking at the UML here, looks like there's a method to calculate BMI. So if I create my button click, public static and this returns a BMI object. So we'll have to we'll come back to this. Calc BMI, yeah. So now let's make an exception class. You can see on the UML that there's an invalid weight exception, an invalid height exception that inherit from argument exception. When you create your own exception classes, it's pretty common to inherit from argument exception. You could also just inherit from the exception class. Fairly common to inherit from argument exception. I've heard arguments both ways as far as what class to inherit from, but let's go ahead and add a class. So we're creating a child class of the parent of called argument exception. We'll do the same thing for invalid height exception. I'm going to stop the recording for just a second. Okay, I just had to remember the syntax. I just had to look it up real quick. So all we have to do in these child classes, let me make sure I'm recording. Recording is back. All we have to do in these child classes is make a constructor along with the error message. So the constructor invalid height exception. So here's our default constructor, and we're just going to pass in the error message that you see on the UML. No semicolon. There we go. And we'll do the same thing. That's the invalid height exception. Same thing with weight. Public invalid weight exception. Okay, and so it's a good thing that we covered, inheritance. Because we got inheritance going on, and we're passing a error message up to the parent constructor, which is argument exception. So those are our exception classes. Let me go back to the UML. Okay, recording's back on. I just wanted to think a little bit ahead on how to solve this problem. Per the UML, we have completed the BMI class, the weight category enumeration, the exception classes, and this BMI calculator method that this belongs to the form. It's a static method, so we'll call it from the button click, and that should get the job done. So I just went back into my form class and thought about, okay, here's where I'm going to do the calculation to calculate my BMI, and then return the BMI with a weight category. Um, except for I don't recall the um, I don't recall BMI categories. Underweight, normal, over. Yeah. I'm just looking up the math. I forget what the math was. Forget what the equation was. BMI formula. Pounds should be divided by inches squared, then to be multiplied by 703 to convert from. Okay, so this is what we're using because we're using pounds and inches. So there's my formula. So 703 times, and I'm just gonna write this down. And I'll get it into my times weight divided by height. height in inches squared. Change that to height in inches. Okay, so now we need to put this into our equation. Let's see what BMI is afloat. Okay, so there's the equation that we were looking for. And we'll create a so now I got to look up the different ranges. So here are the ranges: below 18, underweight. So you could say for us, you say if it's above 30, you're obese. Also, if it's above 25, you're overweight. Okay. BMI is greater than 30. Between I think I got one extra curly here. There we go. Chugging through this, user weight category, healthy, normal. Okay. And so now we will return a new BMI object. passing it the weight in pounds, height in inches, the BMI, and the user weight category. So when we call this static method, it will return a BMI object. And so when we click the calculate button, we'll say BMI, user BMI equals form BMI.calc BMI, passing in the weight in pounds, text weight dot text, and the text height dot text, and we're going to have to get those into float. Okay, so we have not done anything new yet, other than we probably haven't called the static method from within a button click. So this is how you call that static method. It's the name of the class dot name of the method. Obviously this returns a BMI object right here. And that goes into my variable user BMI. And so now we get to update the form. Now, we have not thrown our new exception yet. I'm just building this out without the exception. I'll add the exceptions in next. Don't have any labels yet either. So let's just add one label called label output or label result. Label result.text equals let's just say, and get this prettier here in a minute. Got an extra semicolon. Okay, so okay, 23.7, and the category is normal. So that's working. Okay, and what's new? What's new on this one is invalid height and invalid weight. So we need to say, let me read the, if the user does not enter a number for their weight, display invalid weight in red. If the user does not enter a number for their weight. So that means empty. So let's go back here. let's try to parse it. So going back to the instructions, I read through something a little too quickly. Uh, if the user does not enter a number for their weight, then display invalid weight in red. Make sure to handle format exceptions. And so the way to handle that is that our parse method is going to throw that format exception. So we'll do a try catch here. And if they give us a bad, now this is now barking at us because there's a chance that this doesn't execute successfully. And so we need to change the scope of this. Yeah, that's what we'll do. That's what we'll do. We'll just put the output in there, which makes sense, right? So if I'm not sure if Mr. Smith's voice is coming across on this recording or not, but we're just kind of chatting this through. But the idea is that you're only displaying the output if it's successful. If it's not as successful, then you don't want anything else to display. I don't think his voice is coming across on the recording. Otherwise, we catch the error message. And so now we're getting input string was not in a correct format, which is a result of our message down here. Okay, this is at a kind of at a stopping point. The I did a lot of this, right? But you're at a good point where you should be able to do 2, 3, 4, and 5, right? So that's what I would ask that you go home tonight. I want you guys to try and work through 2, 3, 4, and 5, and then I want you to get as far as you can on number 2 tonight as well, right? That way it's just not, me doing these labs. Obviously, you got to put some thought into it. Now, tomorrow or this afternoon, if you want to stick around this afternoon, you can ask questions on 2, 3, 4, and 5 or number 2. But also, tomorrow during lab time, you'll have plenty of time to ask questions. I know today was just basically me talking and you guys listening, but all of our lab days are not going to be like that. Okay? So I'm going to go ahead and stop the recording here.